In this program, we're going to learn something pretty cool and very important that you can do with method calls. So this is going to be called recursive count. And this program, we are going to be taking a look at recursive programming. So it's a special kind of algorithm that refers to itself. So you can see that the word recur shows up in here. So they're really difficult for beginner programmers to come up with an algorithm that uses recursive programming. But we're going to get a little bit of an introduction, and they're so powerful. And some of the algorithms you can create with them are just blisteringly fast at accomplishing their tasks. So, what we're going to do first is we are going to count. We're going to create a method that will count some numbers. And it'll be pretty straightforward as a process, but we're going to be using a different way of doing it. So we're going to use this method call. So countdown, and we're going to put the number 5 in here. So this is going to go like 5, 4, 3, 2, 1. We're going to count down from 5 down to 1. Okay, so let's create this method here. So public static int. Now, you might think that you would normally do this as a void, but it's going to be very important to keep the integer here because return statements are key to a lot of recursive algorithms. So we're going to do public static int countdown. And it will be receiving our number. Here we go. Okay, so the first thing that I just want to show you here is, because it hasn't come up yet, is that you are allowed to do this. I have a method here. It's got a return 0, and you'll notice that I'm not actually putting the result in anything. I'm not storing it. This program will do nothing, but I'll just demonstrate that no error is received. So when you return a value, I could return 25 here. And then if I run that, nothing happens. So you can return a value from a method and not actually store it somewhere. And that's going to be important here. Although, you rarely actually do this, except for this instance. So it's important to know before we go ahead that you are allowed to do that. Okay, so what is this method doing here? So what we want to do is we want to print the numbers from n down to 1. Okay, so what would that look like? So here's what we do is, this is called function notation. So the function that we're performing on n here is going to look like this. So we're going to start with the number n. And then the next one in the sequence is going to be n minus 1. And then we'll have n minus 2, n minus 3, and so on until we get to like 3, 2, and then 1. You know what, let me separate these with commas. This will be better. Okay. So what we're going to do is we're going to count down from the value of n all the way to 1. So what it'll look like with 5 is if we do the function on the number 5, n here will be 5, 4, 3, 2, and 1. And then we will be done with our process here. Now, the key to this is what we need to do is we need to create a recursive statement here. So this is kind of how this is going to look like. If I have a function of 5 here. So my function counts down to 1. This is actually the same as printing the number 5. And then if you take a look at this, 4, 3, 2, 1, well, I would have received that if I would have gone f of 4. So my f of 5 here will be 5 followed by a function of 4. And then I could continue this if I wanted to do a statement of f of 4, this would be the same as 4 with f of 3. And then continuing all the way down, f of 3 is equal to printing 3, and then followed by f of 2, and then f of 2 is equal to 2, comma, f of 1. And then here's where this insanity stops. F of 1 is just going to be the number 1. So eventually you reach some kind of, I don't need an extra comment here. Eventually you reach some kind of end to the process. And this is important. So in recursive algorithms, you have to create something called a base case, which is usually a reference to when the thing ends. So the two things that we need is we need a base case and we need a recursive expression. So that's essentially, if we did f of n, how can I represent this as an extension of itself? So I want to solve the problem by using the function that I'm trying to solve. So here's what it's going to look like. If you notice, any number that we have here, what we're going to do is we're going to print the number, and then we're going to call a function which is 1 less than that number. So this is what our recursive expression is going to look like. It's going to be n, comma, and then f of n minus 1. Because what we're going to be doing is we're going to print the number, and then we're going to call countdown again with n being equal to minus 1. Okay, so how do we actually program this in here? This is what it's going to look like. We're going to start with the base case, which is a common way to get this started. So if n is equal to 1, what we're going to do is we are going to system.out.println. We're going to print these vertically. Oh my gosh. System.out.println 1. And then we are going to return 0 here. Return 0 is a common sort of like, well, we're done sort of expression. So if I did countdown of 1, let's check to see if this works. What I'm going to do is I should just get the value 1. So if I run this, I'm going to get this error here. So what my program is saying is it's missing a return statement. So this is a pretty common thing when you're writing recursive algorithms is I'm not guaranteed in this scenario to get a return statement, because if I come in here and n isn't 1, it'll run through the entire thing and not encounter a return statement. So you can finish these off, especially while you're testing them out, with a return 0, and I'll show you that we can actually delete this later. So if I run this again, I get the number 1 here. I'm just going to edge my window over a tiny bit so you can see that better. There we go. Okay. So we get our 1. Now, how do we do the rest of this thing? Now, what we've got is our base case here. And if it's not the base case, we're going to have an else here. So otherwise, what we want to do is we want to do two things. System.out.println. We want to print n, the number that we're on. So like in our countdown 5 scenario, the first thing that's going to happen is we're going to come here and we're going to print 5. But then looking at this recursive expression, we want to print the number. And then what we want to do is we want to run the same function, the same method here, on the number n minus 1. So what we do is we do return, and we're going to return countdown n minus 1. So what's going to happen is when we enter here at 5, it's going to print a 5. It's going to hit this statement, and then it's going to receive a function or method call here that will have it do the same process on 4. And then it'll create a new method, and it'll come down here and it will print the number 4 and then run it again with 3. And then it will go back at 3, run it again with 2, and we should get our countdown. So I'm going to put in 5 here as the value, and then we'll run. And now we get the opposite error, which is what you're going to encounter. We get error, unreachable statement. So you can see logically, and it's nice that Java does this for us, there is no way to get out of this if statement without either this thing happening or this thing happening. So I'm going to delete my return 0 at the end because I don't need it anymore. So if I run the program, you're going to see I actually get the number 54321. So let me just help you visualize a little bit what is happening. So this uses something called the runtime stack, which is a big concept that we're just going to only touch on a little bit. So if we enter with 5, here's what it's going to do. It's going to print the number 5. And then it's going to do a countdown 4. And then what's going to happen is as soon as it's going to hit that countdown 4, it'll kind of do this. It'll print 4 and then run countdown 3. And the interesting thing to note here is that the first method has not actually ended its process yet. It's still running. And then what's going to happen is this is going to run, and it will print a 3 and then run a countdown 2. And then it is going to do a 2 countdown 1. And then here, this is the one that's a little bit different because we've reached our base case. It will print the number 1. So what happens is it prints the number 1, and then it hits this return 0, which collapses this one. So this method stops running. And then it realizes that this return statement has finished. And then this return statement has finished. And then this return statement has finished. And then the first one that you actually called from your main program finally stops running, and your program is complete. So this is just a basic example of a recursive algorithm used to count down from the number 5 to 1.